Hello, and today we're going to talk about systems of equations and word problems associated with them. So if you could take a second and pause the video here and try these three problems out and come back when you are finished. For this first one, anytime I'm given 2 points, the first thing I want to do is find slope. So I'm going to do -2 minus 5 over 4 minus 7, remembering that these values have to stick together when we're finding slope. This gives me -7 over -3, which gives me a slope of 7/3. So 7/3 isn't really, I guess, kind of a quote unquote nice number for a slope, but we'll still have to use it to figure out our y-intercept or that b value. So from here, I'm going to take a point and plug it in. This will give me y equals, well, let's use the point 4 comma -2. So we'll get -2 equals 7/3 times 4 plus b. And then from here, I'm going to get 28/3. And I'm going to change -2 to -6/3. That way I have that common denominator and be able to solve for b. This ends up giving me b equals -34/3. So my final equation would be y equals 7/3 x minus 34/3. Okay, for the second one, we're going to try to simplify this out, which means that we are going to have to first combine our numerator. So this 11 does not have a power, right, or at least written there, so it has the assumed power of 1. So this becomes 11 to the 1 plus 7, which would be 11 to the 8th. Remember, when we multiply like bases, we add their exponents, and then we're dividing by 11 to the 5th. 11 to the 8th divided by 11 to the 5th means we're going to subtract our exponents, so we'd get 11 to the 8 minus 15, which would be 11 to the -7th. So we could write it as 11 to the -7th or 1 over 11 to the 7th. Both of these would be acceptable answers. And for the final one, we're talking about numbers that are rational. Remember, numbers that are rational are numbers that we can write as a over b, where a and b are both integers, integers being the key word. So they can be positive or negative. So what we're going to do here, let me just rewrite this one real quick. 11 to the -7th. Okay. So we check, can I write that as a fraction with integers? The answer is no. That's a radical that does not simplify down. This second one we can because it's a repeating decimal. That 0.13 keeps repeating, and so this one is. Yes. And finally, this last one is a no. Now we see a pattern there, right? It goes 0, 1, and then 2 zeros and a 1, and 3 zeros and a 1, but we don't know where that's going to end. So that is not a rational number. So what is a system of equation? The word system means we're going to have essentially two or more equations. When we're solving a system of equations, what we're going to do is essentially find the point of intersection. Okay, so let's take a look at an example of how we could solve this system by graphing. Remember, our final answer should look something like x comma y. So the first thing, I'll graph this line first, and then we'll see where we go from there. So I start with my y-intercept of 3, and then I have a slope of -5/3, so I'm going to go down 5 and to the right 3. That gives me this point. And I could do that one more time just to make sure we get nice coordinates, right? In case this takes a little bit, a while for it to intersect, it's never a bad idea to graph more than one point. And so I'll connect those, right? Because we know our line hits everything in between. Everything in between is also a solution, right? So we could, this weird point of like 1/2 comma, I mean, it almost looks like a half, but it's a little bit of half. This point's a solution on here. This point's a solution. Everything in between is a solution, right? Not just the nice points we graph. The next thing I'll do is I'll graph this line here. I'm going to start with my y-intercept of -3. And now I use my slope to go up 1 to the right 3. And I'll do that a couple times. We could also go down 1 and to the left 3. And very clearly, we kind of see our solution to the system of equations. The solution would be 3 comma -2. So that's where these lines intersect, meaning that that is the system. So, or that is the answer to the system of equations. That's not the system. That's the answer to the system of equations. How we can check if this works is we are able to essentially plug this point in, and it should be on both of these lines, right? That's what a solution looks like. So we go -2 equals -5/3 times 3 plus 3. And that would be -2 equals -2. So yeah, it works for this one. And then let's check the other one. -2 equals 1/3 times 3 minus 3. Well, that's 1 minus 3. Yeah. So we know that this point has to work. This is our solution. However, sometimes we don't actually like having to graph. And sometimes we won't get a nice answer, or at least an answer that hits on an integer coordinate when we graph. Let's look at this set of equations, this system, for example. I'm going to real quick, let's bop over to Desmos for a second. So if we look at this system in Desmos, we realize here's my blue line, right? There's y equals -3x plus 4. There's the y-intercept and everything. Here's our red line. And we realize if we graph their intersection, we find where they intersect, you get the point -0.588, comma 5.765. And of course, Desmos is going to round, it's going to give us 3 decimal places out. So we don't know if this is the exact or if it's going to be essentially a rounded answer. So we want a different way to do this, because if I look at this and I were to try to solve this by graphing, I might say a little bit less than, -1, maybe, maybe a little bit higher, close to 6. We wouldn't have an exact answer really dealing with this. So what we want to do is we want to essentially have another way to solve this, and substitution's that answer. So what happens here is we want to figure out where these equations are equal, meaning that the x and y have to be the same value in each equation. So this y has to equal this y. And so if this y equals this y, we can set these equations equal. We can set 2/5 x plus 6 equal to -3x plus 4. Because again, that's our goal. There is exactly one point where these lines will intersect. That's one of the big rules in mathematics called an axiom, right? And so from here, we're able to solve for it. So the first thing I'm going to do is I'm going to add 3x to both sides. And so I'll get 3 2/5. Let's take 3 2/5. Let's make that an improper fraction. So 3 times 5 is 15 plus 2 is 17. So 17/5 x plus 6 equals 4. From there, we subtract 6 from both sides to isolate the x. And then we multiply by the reciprocal to get x by itself. So I get x is -10/17. So this is just our x value. We get -10/17. And again, there's no way we'd be able to tell by graphing, oh yeah, that looks like -10/17, right? There's no way for us to know that. So we need to be able to use substitution instead. Now, this is just half of it though, right? We need to figure out what the y value is. So what we're going to do is we're going to plug that value back into our equation, and we're going to figure out what y is. So we get y equals, let me do this a little bit more erasing. Y equals 2/5, comma, -10/17 plus 6. So this will simplify down and we'll get y equals -4/17 plus 6. And now I need to change that 6 to 17. So I go, okay, 17 times 6, that's a 2, carry the 4, 102. So we can change this to 102/17. And so my y value is equal to 98/17. 98/17. And we see, okay, can I simplify that down? Well, the only thing that can go into 17 is 17. So we realize it won't divide perfectly. And so our final answer here is -10/17, comma 98/17. Again, no way we could get that solution by graphing. If this process was confusing for you, which I think it probably will be for a lot of people, what I would suggest you do is rewatch this particular section again and try to follow along what I'm doing, right? All right, let's try one more. I'm going to show you how we could do it graphing or by substitution. If I want to graph, I start with the y-intercept of 3, and then I have a slope of 4. So up 4, right 1. I could go down 4, left 1, down 4, left 1, and we can connect that. Again, your line doesn't have to be perfect, right? It's a sketch. And then for our other one, we're going to start at -2, -2, and then we have a slope of -1. So we're going to go down 1, right 1, down 1, right 1, down 1, right 1, or up 1, left 1. And so this one's kind of nice because I get the value -1, -1. This one's not bad to graph because we get a nice solution. However, let's look at what this would be if we were to do substitution. So again, these y's are able to equal each other because we want them to be the exact same value. Right? That's the whole point of systems, is that this is the one point where they're equal. And so now we have these two equations. We add over the x. We subtract the 3. And then we divide by 5. So now we get the x value as -1. Let's try plugging it into the first one this time. 4 times -1 plus 3. That also gives us -1. So we get the point -1, -1. Remember, this has to work with both points, or it has to work with both lines. So I could also check and see if this is true as well. So is -1 equal to -1 minus 2? Well, yeah, that'd be -1 is equal to 1 minus 2. That tracks. So this point works for both equations, and we're able to solve. All right, you try this out. Try it out without graphing. See if you can do it without graphing. See if you can do substitution. If you need to graph, it's okay, but substitution is kind of the way we're going to go. In fact, I'm going to delete this graph. I'm not even going to look at the graphing. So pause the video, try it out. Come on back when you're done. Okay, you're back. So again, y equals y. Let's set them equal to each other. -1/2 x minus 1 equals 1/4 x minus 4. I'm going to add 1/2 x to both sides. And this is where we can really tell who's great with their fractions, because if you can quickly add those up and get 3/4 x, that means you're doing a fantastic job with your fractions. You're going to see fractions all throughout, right? So we want to make sure we're good with it now. We add 4 to both sides and get 3 equals 3/4 x. And then we're going to multiply by our reciprocal to get x by itself. This gives me that x is 4. So I'll plug that back in. Let's plug it back into this bottom equation. Y equals 1/4 times 4 minus 4. Well, that's 1 minus 4. So I should get -3. But we always want to double check. So let's see what that would look like. Let me erase this top. I'm going to plug this back into our top equation and see what we get. Is -3 equal to -1/2 times 4 minus 1? Well, is -3 equal to -2 minus 1? Yeah, so we know our answer is correct. We did it right. All right, here are 3 problems I want you doing via substitution. I want you to try these 3 out. Again, substitution is one of those things where you just kind of need to practice the skill, right? It's going to be tough the first couple times, but as you keep going, you should be good to go. So pause the video here, and we'll come back with all the answers. For the first one, I set them equal. And again, you'll see this on every single one. I'm going to set them equal. Then I'm going to add 1/2 x over, so that way I get all my x's to one side. That gives me 7/2 x minus 4 equals 3. Or 7/2 x equals 7. Multiply by the reciprocal on both sides. 7 times 2/7 is 2. So x is 2. We plug that in, and again, we can plug it to either one, but this top equation would probably be the easiest. 3 times 2 minus 4 is equal to y. So that's 6 minus 4 is equal to y. Y is 2. And if we plug that into the second equation, we'll get the exact same thing. For the second one, we're going to set them equal. Negative x minus or plus 1 is equal to 1/3 x minus 3. Add my x over, so that way I get positive x's on the right. That gives me 4/3 x minus 3 equals 1. Add the 3 over, so I get 4 equals 4/3 x. And now I multiply the reciprocal of 4/3, which is 3/4, and get x is 3. So now from there, if I know x is 3, I figure out which one would it be easier to plug into. I think this bottom one's probably the easiest one to plug into. And so we get negative 3 plus 1 is y. We get y is negative 2. If we do the exact same thing with that top equation, we get the same thing, right? Which is good. That's what we're expecting to see. And finally, with this third one, we're going to set them equal. So we get negative 2x plus 2 equals negative 2x minus 2. And we get 2 equals negative 2. Interesting. So what this means is that we have a set of parallel lines. The slope is the same, but the y-intercepts are different. This means that there is no solution. The lines will never intersect. Now, I will tell you we want to focus more on these and how we can solve them because we're going to utilize that in word problems in a second. But it's good to know that parallel lines were never going to intersect. Let's look at this problem. This is a good old geometry word problem. The length of a rectangular garden is. So length means L, is means equals. Let's get this next part. 1 foot more than, so we're going to add 1, twice the width. Call that 2W. So now I know the length is equal to twice the width plus 1. The perimeter of a garden is 38, so the perimeter is 38. So we need to know how to find the perimeter of a rectangle, right? Perimeter of a rectangle. And so we know the perimeter of a rectangle is 2W plus 2L. And we know that the perimeter of this is 38. So our goal is to try to figure out how in the world we could figure out what W is, right? Because now we have two variables. What are we going to do? Well, hey, we already said L is 2W plus 1. So let's replace L with 2W plus 1. This gets us 2W plus 2 times 2W plus 1 equals 38, which is 2W plus 4W plus 2 equals 38, or 6W plus 2 is 38. So that gives us 6W is 36. That tells me that the width is 6. Now, it doesn't ask for the width, though. It asks for the length. And so 2 times 6 plus 1 would be 13. So the length is 13 feet. Now, we could check by essentially seeing if this makes sense, right? Is 2 times 6 plus 2 times 13 equal to 38? Yeah, but the answer it wants is the length. Now, if we want to go crazy and say, what's the area? To find the area, we'd have to do 13 times 6, and the area would be 78. Oh, not that. The area is 78. Oh, my marker stopped working. Feet squared. All right, last one. I want you guys to try this one out. Pause the video here. Again, if you were stuck on that last one, re-watch it to kind of give yourself a little bit more comfortable with it and try this one out. Okay, so we switched up length and width. Now the width is first. So it says the width is 3 feet less than. Oh, that's big. We don't want to do 3 minus here. We have to do minus 3 because we're taking 3 away from the quantity. And that's twice the length. The perimeter is 36. So 2W plus 2L is 36. And then we're able to plug this in. If the width is 2L minus 3, let's replace W with that. So 2 times 2L minus 3 plus 2L is equal to 36. Then what we have to do is we're going to multiply that out. And we find that we will get 4L minus 6 plus 2L equals 36. So 6L minus 6 equals 36, or 6L equals 42. So now we know the length is 7. So the length is 7. It also asks for the width. So the width would be 2 times 7 minus 3, or 14 minus 3, which is 11. So the length is 7 feet. The width is, or the length is 7 feet. The width is 11 feet. And then it asks for the R. I think I meant to type area in here, right? It asks for the area. And so we would find the area by multiplying the length and width to get 77 feet squared. Now, system of equations isn't a huge focus on what we want you to know before Math 1, but it is a little bit in there, so I wanted to give you guys a little bit of practice on it. You will also find I have a whole playlist on systems of equations if you really want to delve into it. It is something you will learn in Math 1, so if you don't feel comfortable with it just yet, I would suggest doing a little bit more practice and focusing, sorry about that, and focusing on substitution. All right. Have a good day. If you have any questions, reach out to me. Let me know. See you guys.